Hi, welcome to this session on the Open Security Summit January edition. It's Friday, but what a great way to continue on a topic which I believe is super critically important, touches a lot of areas that I absolutely really passionately care about. But also, we're very privileged to have Alvaro, which I know for quite a while, a great security researcher, from a long time in the industry. And one of the things he's going to talk about, which I believe is super critical, is how he's using CodeQL, which is a really great piece of technology that it's kind of appeared recently and has a huge amount of potential. And I kind of really want, in my case, my teams, right, to be using it. But also I feel that there's a lot of great collaboration that can occur and a lot of great potential to really change how we find and detect and even help teams to fix security vulnerabilities. So over to you, Alvaro.
Thank you, Dennis. Well, thanks for introduction. You saved me like a couple of minutes from presenting myself. So this is how Variant Analysis helped secure the fight against COVID-19, or basically how I was able to get remote code execution on the server that hosts the Germany application for contact tracing. And I did that using CodeQL and Variant Analysis. So this is the story of that finding, right? So let me see if I can control my own slides. For some reason, it's okay, perfect. So hopefully today we will learn something about what variant analysis is for those of you that are not familiar with variant analysis, and also how you can use CodeQL, which is free for public and open source projects, and in order to do variant analysis and find security vulnerabilities with it. So we will end up, hopefully this will be like maybe 20-25 minutes presentation, and then we will have time to do some live work on some queries. Actually, I'm pretending to write the very same query that I wrote to find this vulnerability. But if you have any questions about CodeQL, we can spend that time like answering those questions then. So feel free to interrupt me if you have any questions about what I'm presenting or about anything CodeQL related or variant analysis. So first of all, let me go back to 2012. That year, if you remember, there was this Curiosity mission that was on its way flying to Mars, right? So at that time, the NASA Jet Propulsion Laboratory performed a code inspection, a code review of the software that was powering the Curiosity rover. And they found a mission critical bug in the piece of software that was responsible for the entry, descent, and landing software. And this is not the exact piece of code, but it's very similar. And basically it's a function that was taking an array of 12 different doubles, which represents the coordinates of some kind of coordinates. I'm not familiar with the software of this rover. And the thing is that later this function was called by using an array that was shorter in size than the size that this function was expecting, right? So if you are familiar with C, this 12 over here is basically an annotation that is going to get removed by the compiler. And then there is no way of checking unless you perform some additional checks that this array is exactly 12 elements long, right? So if you pass only 3 elements, what is going to happen is that you are going to iterate through all these memory slots, and then at some point you are going to start reading something that is not what you are expecting. It's not the coordinates for landing or whatever this function was expecting. And you're going to start reading some memory that is probably not some in the form of some coordinates, and then that can help like crashing the application. So JPL ran this software, this query. Well, basically JPL at that time partnered with a startup that at that time was called Semol. Now is part of GitHub since it got acquired like almost one year and a half ago. And they wrote a query in order to find more instances of this vulnerable pattern, right? So I know most of you are probably not familiar with CodeQL, so bear with me. I will introduce the basics of the language later, but just so you can have a view of what our CodeQL looks like, this is the query that the NASA ran on the software of the Curiosity rover. And basically, as you can see here, first of all, we are importing some C++ standard library. And then this is very similar to SQL in the sense that we have a from statement, a where statement, and also a select statement. And in the from statement, we are basically defining or declaring some variables like a function and a function call, and then some integers that will hold the sizes of these arrays that are passed to the functions. And then what we are enforcing is basically some logical conditions, right? So first of all, the function has to be the target of the function call. And then we are basically checking the size of the array as it's defined in the function declaration, and also as it's used in the function call, in the call side. So if the actual size is shorter than the expected size, then we will report an issue. So by running this query, NASA was able to find 30 similar errors to the one that they found manually through manual inspection. And what it's pretty awesome is that they actually fixed that vulnerabilities or those bugs remotely while the ship was traveling to Mars. So we all know how this story ended. Basically, Curiosity safely landed on the surface of Mars, and that was basically, or not basically, but a little bit was thanks to CodeQL. So this is an example of a variant analysis, right? So variant analysis is nothing else that try to scale some manual inspection, right? So first of all, you normally find a bug by doing some manual review of some code base, right? So it can be a security review, or can be basically any kind of code review, which end up finding a security related bug or just a regular bug that affects the code. At some point, you want to scale that and look for similar patterns throughout your code base, and not just in that small piece of code that you audited. And then the idea is to be able to somehow dump the knowledge of the people that found that bug in the first place into some kind of pattern or query that then you can run on not just on that code base, but also in additional code base. So ideally, you should be able to take that knowledge and then share it with the community so people can use it as well, and also maybe adapt it so they can get better results in their own code bases, because maybe there are some differences that need some kind of adaptation, and also reduce false positive and contribute it back to the community. So
just on that one, can you go back? Just add a comment here. Like, I highly recommend who's watching to go back and see the session that Petra and Abbas and Luke just did on scaling instance response, because one of the things that you should do during an incident is actually this variant analysis. So even when you have an incident or an exploit or somebody finding a particular bug, in a way you should always think of it as the canary in a coal mine. You should always think that that could be one of many instances. And one of the reasons why I really like to allocate lots of resources to incidents is because what you really should be doing in an incident is reverse engineering the bug, or maybe the vulnerability or the attack that you just had, or whatever just happened, write the query, and then look for the rest of your source code, in this case, for the same problem. Because you could have way bigger problems that, was the one that you happened to hit with a bug, or you happened to hit with a particular risk condition that was very benign, but it's very important to do this variant analysis where you look for the same instance of that across the board, right? Yeah,
exactly. And not just on incidents, but also when you have a security researcher reporting a vulnerability to your company, or maybe through a bug bounty program, you may want to make sure that you are not fixing just that instance, but actually other potential instance. That is what happened. The basis of this story that I'm about to tell started in 2018, when a security researcher reported a remote code execution vulnerability in Sonatype Nexus repository manager, which is basically an artifact server that is developed by Sonatype. And this vulnerability was a Java expression language injection. So it was able to lead to remote code execution, but only for administrators, for administrators. And then two years later, at the beginning of this year, I performed a root cause analysis of this bug, because basically the advisory was not very clear in what was the root cause, how it was possible to lead to this EL injection, right? So by analyzing the patch and the code and the information that was available, I found out that the root cause was basically an insecure usage of the Java Bean Validation API. So if you are not familiar with this API, basically it allows you to enforce some constraints on the Java Bean properties, basically by annotating them with some annotations. So you can, for example, annotate the Java Bean fields with something like decimal max in order to enforce that the value of that decimal is actually shorter than a specific value that you define. Or you can, for example, specify that a string needs to be in the form of an email pattern, for example, or something like that, right? So most times you need to perform custom validation, because the ones that comes with the Hibernate library, which is the reference implementation of this API, may not be enough for your business, right? So this was the case in Nexus, where basically in the front end, you were able to define new users and also update existing users, and you were able to assign roles to these users, right? So when you submit that information to the backend was verifying that those roles were valid. And one of the things that they did was basically check that the array, the collection of roles that you were submitting were valid and they were existing roles. So they went through the list of roles, checked if those were valid, and then if they were not, they were pushed into a missing list. And then there was this function here, like build constraint violation with template, which was generating an error message. So when you look at this code, normally most of the developers won't see a problem here. So maybe, I don't know, we can check, is there anyone like know what the problem with this code is? Maybe you, Denise, or Esteban? I know you, at least you, Esteban, you should know about it.
It actually ends up being evaluated in some kind of expression.
Yeah, so exactly. So the important part here is this with template. So basically, this is treating the string as a template, as other template engines such as FreeMarker or Velocity or other template engines. This will allow some kind of expression interpolation, right? So if we go to the specs, we can see that at some point in the Vim validation 1.1 version, they added support for unified expression language, which basically means that you can use it in order to resolve variables from a template context. We have an example down here. We have this price, and then we have annotation, this annotation decimal max, which is going to enforce that the price is no higher than 100,000. And if that's the case, then an error message will be generated saying that the price must not be higher than, and then this EL expression here. So this is completely safe because this error message is hard-coded, it's a string literal, and no attackers can actually modify it. But if we go back to the previous slide, you can see that when writing custom validators, these are things that this is the only way of generating the error message, and it's always treating the string as a template. So if you allow untrusted data flowing into this API, this is going to allow attackers to run arbitrary expressions. So we can see an example of what happened in Nexus. Basically, if you submit this request to the server, then as you can see here, we are creating a new user, test123, and then we are assigning a non-existing role, an ex-admin, which has this EL expression that is basically adding some numbers. The response is throwing an error saying that there are missing roles. And then if you notice, this role is actually evaluating the EL expressions. So in this case, we are basically just adding some numbers, which is not a big problem, but obviously using Java Unified EL expressions, you can run arbitrary Java code, which will allow to compromise the server. So at the beginning of the year, I performed a variant analysis of this finding, and then I wrote a CodeQL query to find more instances of this pattern, of this bug. So I was surprised to find 4 more instances in Sonatype Nexus codebase. 2 of them were post-authentication, so they were similar to the ones discovered in 2018, but 2 of them were even more severe because they were pre-authentication. In addition to those 4 variants on the same code base, we were able to find many others in other open source projects. So later I checked in this query as part of the CodeQL open source repository, which powers the lgtm.com and GitHub code scanning. So for those of you that are not familiar, lgtm.com is basically a site where you can run arbitrary CodeQL queries on any open source project. This is the case, for example, for the Corona Warn server, Corona Warn app server. That is the one that we found the vulnerability. And code scanning is basically CodeQL powering GitHub. So every time you check in a new pull request, you can run CodeQL scans on that pull request to make sure that they are not introducing any vulnerability in your code. This is now completely free for open source projects. So if you want to give it a try, you just have to go to your GitHub repo, and then in the security tab, just look for code scanning, enable it, and then it will create a GitHub action to run these scans on every pull request. So as a result of adding this query to the open source repository, there were new projects that were found to be vulnerable. But then I went on paternity leave, and when I came back, I reviewed some of the new findings, right? And one of them was pretty interesting because it was on the Corona Warn app server, which is basically the backend server which hosts or handles the notifications from the contact tracing apps in Germany, right? So this is a very large open source project. It was developed in May, I think, and in June, according to SAP, which is the main maintainer and developer of the application, they said that more than 7,000 people, community and project members, participated in this project. And as they said, it's the largest open source project ever implemented in Germany on behalf of the German government. So SAP fixed this vulnerability very quickly. Actually, I think they were pushing the fix in production like in 4 days or so. So very, very good response. And it actually made it to the news in different US and German news, but all of them were highlighting that the collaboration enabled by the by this software being open source, basically. So basically, there were a lot of eyeballs looking into this source code, and because it was open source, we were able to find and identify this vulnerability before, bad guys could have found it and disrupt the service of contact tracing in Germany. Okay, so this is how the vulnerability looked in the Corona Warn app. Basically, it's very similar to what we saw in Nexus. We have this isValid method, which is overriding the constraint violation interface. And then in this case, what we are validating is this submission payload object, which is basically the object that is sent from your mobile application when you say that you have tested positive in COVID-19. So it contains a lot of fields which need to be validated. One of the fields is the origin, the origin country. And then they perform this check where the submission payload is passed into this other method, and we get the origin, and the origin is concatenated into this a string that is then passed to the add violation, and then the add violation will end up calling the build constraint violation with template that we mentioned before. If you want to read more about this whole category and the finding of this bug, you can check this URL down here. And if you think about it, this is normally the case, right? So if you find a vulnerability, it doesn't normally occur in isolation. So if the developer makes a mistake, either a security vulnerability or just a bug, it's not normally because they were thinking about something else that morning. It's because they are not aware of a vulnerability class. They are not aware of the dangers of a specific API. So if they make this mistake in a small piece of their code, then there are chances that they have introduced the similar bugs in other pieces of their own code. So it's important to perform this kind of variant analysis in order to find more instances of those bugs. Once that you identify one, you want to make sure that you try to kill the whole class in your code base. But if you think about it, it's not something that you want to do manually, because finding the first instance may be costly, but if you want to take that security team and get it to manually scan or audit all of your applications, that is going to take a while and it's going to be costly. So we need to automate this. And that's where CodeQL can really help. So for those of you that are not familiar with CodeQL, it's an expressive query language, but not just the language. CodeQL also refers to the analysis engines and also the command line interface and IDE tools. And the basic idea behind CodeQL is that it treats the code as data. So in the same way that you use SQL to find data in your databases, we want to treat your code as a database and being able to query your code in a similar way that you query a database. So we need a query language that allows you to somehow express this knowledge that the security auditors have in mind and try to dump it into some kind of query that then you can run on multiple projects. So what can we do with CodeQL? So we already mentioned you can find bugs, not just security bugs, but any kind of bugs. You can use it to find security vulnerabilities. You can use it for anything where you need to query your code base. Think about things like refactoring your code. You may want to look for similar parts of the application. You need to query maybe where some critical operations are being done in order to add some login statements or something like that. So everywhere where you need to query your source code, you can use CodeQL. Also, it makes your analysis more efficient and precise. And it's designed in a way that you can reuse that knowledge in other projects and share it with other security teams in order to share information and being able to augment the scope of these queries. So there are like, I don't know, thousands of languages. So why do we need a new language? What's different about CodeQL? So in the first place is a logical language. So basically it's composed by multiple logical clauses that are combined with multiple logical operators. And then it's declarative, right? So it's very similar to SQL in the sense that you don't define how you want to perform your queries. You don't care about how, I don't know, a database, table, a row, or a column are selected or are inspected through when running a SQL statement. What you care about is what you want to find. So in SQL, you find, I want to find this information from these tables when you are combining that with another table and so on. You don't really care about how you are going to find that. So you're not going to see anything like if-else statements or for loops in CodeQL. Also, it's object-oriented, which means that you can benefit from all the benefits from object-oriented paradigms. So things like encapsulation, inheritance, composition. This is not very common in logical declarative languages, but we found it very useful in order to be able to reuse different elements of the queries, so you don't have to write the queries from scratch every time. So first of all, you can reuse all the standard libraries, but even if you are writing some queries for some of your own libraries, for example, then you can create classes that you can extend and reuse in your queries without having to write all that knowledge again and again. It's a read-only language. For example, there are no assignments in the code, but also the database is read-only. You cannot insert or update the database. Once that you generate a snapshot of your source code, then if you want to query a newer version of your source code, you need to actually generate a new snapshot of the source code. Also, it's equipped with a rich standard library, so you don't have to care about how to match basic elements like, for example, a method invocations or variable declaration. Everything is in the language, but also if you are writing queries for frameworks that are already supported, like for example, the Spring framework, you can also benefit from the standard libraries for those frameworks, and you will have classes that are representing things like a controller or a controller method or something like that. So what does a query looks like? So we already saw one in C++. This is a similar one in Java. Basically, we have some imported statements which are going to bring us all the functionality for a given language and all the standard libraries for that language. And then we have the from, where, and select statements that we mentioned before. In the from statement, we normally declare some variables. So that's what we want to find, right? So we want to find all the tuples that are composed by a method access and an expression. And then in the where, what we are going to do is we are going to constrain and limit down the number of tuples that satisfies our conditions. So in this case, we want to make sure that the method access is invoking a method that is called build constraint violation with template. And then we also want to connect these two elements in the tuple by saying that the expression is the first argument of this method invocation. And then for those tuples that satisfies these conditions, what we are presenting to the user is the actual expression, which is the first argument of the method call. And then a string literal saying that this expression is may be executed as Java EL code. So at this point, we are not performing any data flow analysis. So we are not sure about if this expression can be controlled by an attacker or not, but this is just a very simplified version of the query, which will find at least invocation of this function, this method, sorry. So at this point, I think what I wanted was to write some queries. Actually, the query that I used, or a simplified version of the query that I used to find these bugs in Nexus, Drop Wizard, Corona Warn App, and so on. So while I'm changing screens, if you have any questions. Okay, so let me share. So can you see the terminal now?
Yes.
Okay, perfect. Thank you. So first of all, I'm using Vim in this case. This is not the official way of writing CodeQL. So let me switch back 1 second. So the official way of writing CodeQL, or the official or the supported way of writing CodeQL queries is using the CodeQL extension for VS Code. And this will enable you to basically, will help you with a language server which contains completion. It will allow you to run queries, review the results, do some debugging operations, and so on. But I'm going to use a different one. First of all, because I wrote it. So this is the CodeQL extension for NeoVim. And also to show you that CodeQL can be integrated into any tool. So basically an IDE, text editor, or maybe some shell scripts or whatever you want, right? So if you want to give it a try, this one is located in my Pontester CodeQL npm, but I probably suggest you should start with the VS Code extension. Okay, so back to NeoVim. So first thing that we need to do, either in VS Code or NeoVim, is set the database that we are going to analyze. So I have the database already prepared. I'm going to use the set database to point to the Corona Warn app database. And then we can start writing our queries, right? So if you have any ideas or any suggestions of something to find, just let me know. I'm gonna start like writing some simple queries. Okay, so from, I don't know, method, let's write the same one that we saw before, from method access, which is basically a method invocation, where the method being accessed is or has a name that is called template, and then select NA. So this is a very simple query. I'm basically looking for all the invocations to this function, and to run it in my NeoVim plugin, you just have to write or run query. By the way, CodeQL is compiled into an optimized version of Datalog. So this compilation can take a while, but it's something that you do normally once. If you run the same query over and over, compilation is skipped. So we found one result. In this case, this function is only invoked in this method over here, in the add violation method that we saw before. So if we go back to the query, we can look for something, I don't know, maybe if you have any ideas, just let me know. Otherwise, I'm going to look for example, I'm going to show you how to use object-oriented features like writing a class. So for example, we want to find all the controllers, or yeah, all the Spring controllers maybe. So what I'm gonna check in this case is that a Spring controller is a method, or in this case, a class, which is annotated with an annotation and this annotation is normally in the form of request mapping, but it can also be something like post mapping, get mapping, delete mapping, and so on. So we are going to do something like this. And let me see if we have. sorry, this method already exists in the standard library, so I need to use my own name. And now what I want to find is, are all the classes where C, like the class is an instance of my Spring controller. So as you can see, even if you are not familiar with the language, you get an idea that it's kind of easy to write queries, in the sense that, well, you need to be familiar with all the syntax, for example, but once that you know the basics, you can get a lot of help from auto-completion, right? So for example, if we have an annotation, this may be a problem with my plugin. Sorry. So you get an idea that, I don't know, maybe I'm trying to match an annotation and I don't know how to match it. By just writing get, I get the auto-completion to propose some ideas that I can query, like the file where this annotation is defined, the type, the location. Those are basically the most interesting ones for this type. But you get the idea. It's very, I would say that is intuitive. Anyway, if we run this query, sorry. Sorry, I didn't run the query. I ran a quick evaluation of the class. So it's finding, it was matching all the classes. So if we run the query, we found 3 different classes which are Spring controllers. We have the callback controller, the fake request controller, and the submission controller, that is the one that was vulnerable. So if we check them, for example, we can see that this one is annotated with the request mapping that we were matching, and actually it's also annotated with validated. And then same thing, for example, with this one, but this one, for example, is not validated, right? So they decided that validation was not required for this because it's the one that is responsible for handling fake responses, fake requests. So we can use that to extend our query. Like, for example, we can.
May I suggest an example, Alvaro?
Yeah, sure.
So now that you're working with Spring controllers, what about looking for any controller endpoint that returns a string saying forward, column, and some control input? That could be used like a, to do a file read, because if you forward to, web XML, something like that, you could end up, reading a file.
Okay, we can try it. I don't know if
But
I will be able.
Just a suggestion, since you're playing with controllers.
Okay, let's call it forward Spring controller method, which is a method, it's not a class. And well, the thing is that I don't know if the source code will contain something like this, but we can write the query, maybe we'll return zero results.
Cool.
So we want to find a method. So we are extending the method. And this method is annotated normally with the same annotation with request mapping. So we are going to keep this. And then we want to say that, okay, so so this get closing. Okay, so what we want to check is that that exists. I don't know the type of this, a return statement. And then we want to check that the red get enclosing callable is our method. So is this. So this will basically just find all the methods with a return statement. So it's not very useful, but we can then refine this clause over here. To be honest, I'm not familiar with this kind of with the return statements.
Spot, so go ahead and do
I like because
else.
that's what I was expecting from this kind of workshop. But the thing is that I should be using the documentation, and I can share both windows. So anyway, let me see. Can be resolved to type for type. Okay, so this is not the name. Result. Okay, so this returns an expression. So this can be the expression.
Yeah, at least if you for now just restrict it to returning string, then you will lose all the other ones returning maybe a model view or a view. So that's a start.
Yeah, and this can be used to then check that the string has a compile constant expression that starts with forward or redirect and so on. So that's the idea. And so that's the idea of how to define the sink, right? Because what you want to find is some places where trusted data flows into the forward return statement or expression in this case, so that an attacker can control what part of the application is going to be forward, and then maybe leak some internal files. Or so in order to do that, you need to do data flow analysis, and I think that we can run that example now. So let's keep this for later. And what we are going to do now is we are going to basically explain how you can define or write a data flow query. So for that, we are going to use some boilerplate. So what we need to do, basically, we need to extend a class that is called, not this one, sorry. This one. So we need to extend taint tracking configuration, right? So this is going to be my bin validation config. And then what we want to write now is what are the sources. Let me remove the errors and the sinks. So basically for a taint tracking configuration, what we want to find is the data flow between a source and a sink. And in order to do that, you need to override the is source and the is sink predicates, but you can also define other methods, like other predicates, such as the ones that allows you to extend the taint steps, the pass-throughs, and also the sanitizers or the barriers. So what we want to do in this case is find or treat the first parameter to the isValid method as the source of our data flow, right? So in order to do that, what we are going to do is basically look for In this case, it will be a method. Sorry. And this method is named sorry. So we are looking for a method that is called isValid, and then the first parameter of this method is what is going to be treated as our source, right? So one thing that you can do with the CodeQL extension for VS Code or with my NeoBeam plugin is that you can evaluate small pieces of your queries. So in this case, I want to evaluate this small piece in order to make sure that I'm matching all the method declaration of a method called isValid. So I'm going to evaluate that. Contains multi, okay, I need to remove this, sorry. I need to save it because otherwise it's going to run the same one. So we found 6 different places in the code where you where there is a method that is called isValid that is being defined, right? So this is not very accurate because I'm not checking the type of that declares this method, but for now I think it's enough. So for the sync, we want to make something similar.
Sorry, Alvaro, I just had a question. You know, when
Yeah, sure.
when you go into that code complete, right? For you know, for one of those things, those kind of values you have, they are because CodeQL understands Java, right? They're all Java specific CodeQL kind of methods.
Yeah, so basically what is going on here, well, this is powered by the CodeQL language server, and it's basically returning all the properties of a given type. So if I'm, for example, completing on M, which is a method, I can also go to definition, and this will take me to the definition of a method in the standard library for Java. So everything is open source and it's in the CodeQL repo, and here you have the definition, for example, of method. So here you have all these get source declaration, get an override, get source override method, get signature, all the methods that will populate the completion methods.
But this is already written in CodeQL, right?
Yeah.
Very cool.
So this is what we are importing, where we are importing the Java standard library. We are importing, for example, this member QL library file, which defines what a method is in Java, what a variable is in Java. So those are not exactly the same as you will find in Go, JavaScript, Python, C, C++, C#, or any of the other languages that are supported by CodeQL. Okay, so now we want to define the sync, and in this case, it's not going to be a method, it's going to be a method invocation, right? That in CodeQL is called method access. So here we want to make sure that the method that is being accessed is called build with template. And then we want to check the argument instead of the parameter, because it's a call site. And then in this case, the sync is an expression. Also, M does no longer exist. It's part of the previous predicate. Okay, so we can do the same thing. We can select this piece of the query and then evaluate just this small part. And we will have only one place in the code, which I don't know why it's pointing here, sorry. So that's a bug in my extension, I think. Anyway, let's find, now that we know that we have one sink and multiple sources, let's find all the data flows. So that is all the sources and sinks that satisfy the has flow path property in our bin validation configuration, right? So if we run the query, we should get one result that is the one that led to the remote code execution in the Corona Warn app server. So as you can see down here, it's still compiling the query. This can take a little bit, but it's just something that you only do once. And then it's running the data flow analysis on the whole code base. And as you can see, we got...
So when you say it's compiling the query, is he actually loading all the source code, mapping to the source code, or just all the queries, the CodeQL code?
So it's compiling the CodeQL query into an optimized version of a different language that is called Datalog.
Okay.
And then that is the final query that is going to be run against the code base database, right? So all that time that was you could see the compiling query, it was just building the final query that it was going to be compiled, and then running the query was very fast.
Okay, cool.
So yeah, I'm sorry that I have some bug in my extension. It doesn't allow me to jump to the source code. So what I'm gonna do is basically run the query again. That's my fault. It's not CodeQL fault. My plugin, I don't think if anyone is using it except for myself. So it's not very well tested.
And eventually what you want to have is this library of all those, like in this case, your bin validation config, right? So that almost becomes a library of that, right? That you use.
Yeah, so in this case, for example, this configuration is very specific because I only consider this as a valid source for this particular sink. But you can also reuse some existing classes, like, for example, the remote flow source, which means any untrusted source coming from a web browser or any web API. And yeah, now we have the same result with 3 different steps. So we can see the data flow here. The first step is, well, this is actually the sink. This is the source, which is the submission payload, and it ends up flowing into the build constraint violation. So that is for the demo. I think we have 3 minutes left, and probably...
Oh, we have a bit more. Somebody wants to ask a couple more questions.
Okay. Yeah, so now we can have some questions, but there is something that I want to show you before. Let me show you the slides again. So, well, I wanted to leave you with some resources about CodeQL, about this whole insecure bin validation class that is not very well known, about how we found this vulnerability in the German server, and also some CTFs, some games in order to learn CTF CodeQL by playing CTFs. Also, letting you know that on December 4th, so that was like many months after the initial finding, but finally Hibernate Validator, which is the reference implementation, decided to disable the expression language evaluation by default. So it's now an opt-in for developers. So now the default is secure. And what I wanted to share you is that, well, if you want to learn and contribute to CodeQL by submitting your own queries, then you can get some bounties. And to get you an idea of how much we gave in bounties last year, or this year actually, we gave $100,000 in bounties for people which contributed different queries, like, I don't know, LDAP injection query, for example, in Java, was something that was not part of the core queries, and it was contributed, and you can earn between $1,000 maybe and $4,000 by contributing queries. So that's another motivation for learning CodeQL.
Mm-hmm. Are there rule packs of CodeQL for languages?
Yeah, so you can go to GitHub CodeQL, which is where all the queries are stored, which are the rule packs, basically. You can go to Java 1, for example, and then CodeQL source. And then there are some queries for quality kind of bugs, complexity, that code, etc. And then you have the security ones that are classified by CWE. So for example, if we go to the 94, we will see the insecure invalidation, which is the one that we saw. This is the full query. So as you can see, the source is an instance of any remote source, not just the isValid first parameter, and the sink is the method of the build constraint violation with template. But in this case, we are using object-oriented features in order to define where this the build constraint violation as a method and so on. So we are checking the type, which we were not checking in my sample query, and so on. So this is a sample query from the standard rule packs.
Yeah, and I think, I guess what you now want is to start, you know, to inject that and run all those rules against a particular code base on every build, right?
Yeah. So in CodeQL, you have something that is called CodeQL suites. So basically, those define a set of queries that you may want to run. So you can run like all the queries, for example, for Java, or you can just run those that are security related. Those are, for example, the ones that are run in code scanning. That is the integration with GitHub repos. So basically, this one is importing from a different library. And you get the definition of the, like for example, all the security ones are defined in this CodeQL suite here.
Cool, nice. I was just actually looking at the C# ones, and then the idea is there already GitHub Actions that you can use to run this, right?
Yeah. So if you go to your own repo, and well, you have actions that you can find in the marketplace. But I don't know if you go, let's say that Lua is not supported by CodeQL, but and this plugin is written in Lua. But if you go to the security, where is it? Security tab, and you enable code scanning, you can enable CodeQL scanning, which is not enabled because Lua is not supported by CodeQL. But if it was supported, then you can set up as a workflow, as a GitHub action. So it will basically create a pull request with the action workflow, and you can just merge it and get it in your repo with a couple of clicks. And you can also integrate other applications, not just CodeQL, but you can run Shift-left, Security Warrior, Sneak, Fortify on Demand, and some others.
Very cool. Yeah, I mean, I think what we need now is to do another session next month, right? And I really like your idea of doing a more in-depth kind of hands-on, you know, maybe with some good exercises for the participants, right? Mm-hmm. And I think what would be cool is that if you then even say, you know, bring your own questions, right? You know, so somebody maybe try a bit and then, you know, maybe ask questions about, how to use CodeQL for specific scenarios.
Yeah, you bring your own questions, and I will bring my own CodeQL expert to answer them.
Cool. Brilliant.
This is an example of a Java repo, and if you can see, I can set up this workflow, which will basically create a pre-populated workflow with all the actions you need to or the steps or job steps that you need to do to run the analysis. So this is triggered by a pull request. So basically, every time that your repo get a pull request, it will will start a scan, and will scan the project.
Very cool. Yeah, GitHub Actions is a massive game changer, man. It's like,
yeah, it's pretty awesome.
Yeah, and makes a massive difference. So cool, man. All right, anybody has any other questions? If not, we can end it.
And Esteban, I promise you to reply on your get the return statement, how to match it, and
thanks.
I will send
it's
it
just a fun example.
No, and actually, someone submitted a similar query for Open Redirect in Spring. So they were taking the redirect prefix instead of the forward one, but the query is basically 99% the same. So you can even reuse it.
Nice.
Actually, as somebody wrote this for those MVP, what's it called, MVC vulnerabilities and serialization vulnerabilities that we were finding, man, almost probably a decade ago, right?
Yeah.
Because I remember when I was doing security reviews, I kept finding them everywhere, right? So yeah, I'm sure that now there's rules for that, right?
Yeah, for deserialization, sure. And actually, I was planning on writing a query for something you are very familiar with mass assignments.
Hey, that's the one I was talking about, the mass assignment stuff. Yeah.
Mass assignments. So yeah, that's something that I want to write a query for. There is no query for that at the moment, at least that I know of. And that's something that we can do in the workshop, maybe with the guys from the professional teams of CodeQL. Or maybe if you want, Dennis, I invite you to what we call LiveQL, which is a stream workshop where we have one of our professional services gurus, and then to propose some categories, and then together we write that live in a Twitch stream.
Cool.
So you are invited. Just let me know if you want to attend or participate as the guest
can
in the next one.
You extend that to some members of my team?
Yeah, sure.
Yeah, and also, we're a big GitHub customer, right? So
cool.
So we got all that stuff. Cool, man. Look, I think we can. All right. Thanks for everything. I can end the recording and see you next month.